Hello students, today we are going to start new chapter known as engineering curves. So let us start with the classification of curves. So curves are classified into conics, cycloidal curves, involutes, spiral, helix. Conics are further classified into triangle, circle, ellipse, parabola, hyperbola. Cycloidal curves are further classified into cycloid, epicycloid, hypocycloid, and cycloid are further classified into superior trochoid, inferior trochoid. Epicycloids are further classified into superior epitrochoid, inferior epitrochoid, and hypocycloid are further classified into superior hypotrochoid, inferior hypotrochoid. Involutes are further classified into involutes of circle, involutes of line, involutes of polygons. Spiral are further classified into Archimedean spiral and logarithmic spiral. There isn't any further classification of helix. So let us start with conics. Conics are the curves of intersection of the cone. So let us first of all understand the figure of the cone properly. So this is the cone. This will be the base of the cone. These are the axes of the cone. This will be the apex point of the cone, and these are the generators of the cone. Make sure that cone has infinite generators. Now let us discuss the definition of the conics. So when a cone is cut by a cutting plane at different positions with reference to the axis of the cone, then the curves of intersection are known as conics. So the different intersection of the cones are known as conics. So now let us explain the different intersection of the cone. So to understand the different intersection of the cone, we have to cut the cone by using a cutting plane. So if the cone is cut by a cutting plane passing from the apex point, and if the cutting plane cuts the base, then the curve of intersection is a triangle. If the cutting plane is parallel to the base of the cone, then the curve of intersection of the cone will be a circle. If the cutting plane is inclined to the axis and cuts all the generators of the cone, then the curve of intersection will be ellipse. Now if the cone is cut by a cutting plane parallel to one of the generator of the cone, then the curve of intersection will be a parabola. And if the cutting plane cuts the cone parallel to the axis, then the curve of intersection of the hyperbola. So the curve of intersection are known as conics, and the conics are triangle, circle, parabola, hyperbola, and ellipse. So now let us start with ellipse. So now we are going to explain about different methods to draw an ellipse. So here is the first method to draw an ellipse, which is arc of the circle method. The question is like this: draw an ellipse by arc of the circle method having major axis 140 mm and minor axis 100 mm. After drawing the curve, also draw a normal and tangent at any point as on the curve. So now we have to draw an ellipse using arc of the circle method. The given data is major axis 140 mm, minor axis 100 mm. So first of all, we have to draw the major axis and the minor axis. AB major axis, CD minor axis. Make sure that AB major axis and CD minor axis are perpendicular bisector of each other. So the distance from O to A is equal to O to B, and distance from O to C is equal to O to D. After drawing the major axis and minor axis, the first thing is we have to find out the focus points of an ellipse. So to find out the focus points, we have to measure O to A distance on the rounder. We have to measure O to A or O to B distance on the rounder, and we have to give an arc from point C on the major axis on both sides, on the minor axis on both sides. The intersection of these curves on the major axis will give us the focus point. So this will be the focus point F1, this will be the focus point F2. Now before discussing the matter further, first of all let us discuss about the given data. In this question, here the major axis and minor axis are given, so we have find the focus point. But sometimes in other questions major axis and focus are given, major axis and focal length are given. At that time we have to find out the minor axis. So how can we find out the minor axis from major axis and focal length? For that we have to measure O to A distance on the rounder or O to B distance on the rounder, and we have to give an arc from the focus points on both sides. It will give us the minor axis. Now sometimes in place of major axis and focal length, minor axis and focal length are given. So at that time we have to find out the major axis. Now how can we find out the major axis if minor axis and focal length are given? So how can we find out the major axis? So for that we have to measure this distance C to F1, and we have to give an arc from O on both sides of the minor axis. So this length will give us the major axis. Not every time major axis and minor axis are given. Sometimes major axis focal length are given, sometimes minor axis focal length are given. So at that time we can find out the required data by using the drawing, by taking the arc. So right now you have find the focus points from the major axis and minor axis. O to A, give an arc from C on both sides of the major axis. It will be the focus points, or it will give us the. So after finding the focus points, what is the next step? So the next step is mark points in between F1 to O. Randomly mark points in between F1 to O randomly. 1, 2, 3, 4, and the center point is 5. So mark this distance randomly in between F1 to O. So after marking this point, what will be the next step? So first of all we have to measure A to 1 distance on the rounder, and we have to give an arc from focus points on both sides, 1, 2, focus point F1 and F2 both on both sides of the major axis. Then after measure B to 1 distance on the rounder and give an arc from the focus point F2 over here like this. This arc will intersect the arc which we have taken measuring the distance of A to 1, and we have given the arc from focus point F1 and F2. And then after second step is measure the distance of B to 1 and give an arc. It will intersect this arc that we have taken from A to 1. Now same, measure the distance of A to 2 on the rounder, give an arc 1, 2 on both sides of the measure axis, make sure that we have to give the arcs from the focus points. Then after measure point 2 from B, then give an arc from focus point F2, mark the intersection points, and F1, mark the intersection points. Then after measure A to 3 distance on the rounder, and give an arc from the focus point F1, F2 on both sides of the measure axis. Then after measure B to 3 distance on the rounder, give an arc from the focus point F2, give an arc from focus point F1. Then after measure distance from A to 4 on the rounder, and give an arc from focus point F1 and focus point F2. Then after measure distance from B to 4 on the rounder, and give an arc from focus point F2, focus point F1, mark the intersection points. Then after measure A to 5 distance on the rounder, and give an arc from the focus point. It will intersect at C and D. It will intersect at C and D, because when we have find the focus points, we have measured this distance and we have given arc from C to find out the focus point. So whenever we measure A to 5, it will intersect at C and D. Now mark these points. So now after marking these points, give the name of these points: P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12, 13, 14, P15, P16, and draw the freehand curve passing through these points. That freehand curve will be an ellipse. Draw the freehand curve passing through these all points. So this curve will be an ellipse. Now after drawing the ellipse, here in the question it is also given that draw a normal and a tangent at any point S on the curve. So first thing is, we have to mark that point S on the curve at any point on the curve. That means we have to mark the point S on the curve. So let us mark the point S on the curve over here, point S. Now to draw the normal and tangent, connect this point S to focus of point F1 and to focus of point F2. Then after, draw a bisector of this angle F1 as F2. We have to draw the angle bisector of F1 as F2. So for that, first of all, make an arc or cut on an arc on the F1S line and F2S line. Then after, from same distance or from having same arc length, make another arc. We will intersect at these points and join this point S to this point. This point is S1. Then the bisector of this angle, will be the normal to the curve, Now tangent. So to draw the tangent, we have to draw a line perpendicular to the normal from point S. So that point will be or that line will be the tangent. So we have to draw a line perpendicular to the normal from point S will be the tangent. Now let us discuss the definition of the ellipse by using the drawing of the ellipse. So ellipse is a curve traced out by point P moving in a plane such that the sum of its distances from the fixed points will remain constant. Now what are the fixed points? Fixed points are known as the focus points, and moving point is a point on the curve. So let us mark any moving point on the curve. That moving point is P1. So what this definition tells us, ellipse is a curve traced out by a point P moving in a plane such that the sum of its distances from the fixed points will remain constant. So if P will be a moving point, so the sum will be F1 P1 plus F2 P2 will remains constant. Constant means if we are taking one another point, that is P2 point, so F1 P2 plus F2 P2, these both distances will remain same. The summation will remain constant always. So this summation and this summation will remain same, and the sum will be equal to the length of the measure axis. The sum will be equal to the length of the measure axis. So ellipse is a curve traced out by point P moving in a plane such that the sum of its distances from the fixed points will remain constant. Summation, that means we have to measure the distance of moving point from fixed point F1 and fixed point F2, and we have to take the summation of these two distances, and this summation will remain constant for each and every point on the ellipse. So by using this definition, let us explain this question, which is one of the example to draw an ellipse. So this is the question in terms of definition. One question is given directly over here, and other question is like this. Two fixed points A and B are 100 mm apart. Draw the curve traced out by point P moving in a plane such that the sum of its distances from A and B remains constant and equal to 120 mm. So you have to do this sum in practice. So fixed points are focus points. So the distance between F1 and F2 is 100 mm, and the summation will be equal to the length of the measure axis. So here the summation is given. The sum of its distances from A and B remains constant and equal to 125 mm. So you have to draw, or you have to practice this sum by taking these two dimensions. 125 mm is measure axis and 100 mm is the focal length. So do this sum in practice. So this will be the definition of the ellipse. Ellipse is a curve traced out by point P moving in a plane such that the sum of its distances from the fixed points will remain constant. Now comes on the definition of the hyperbola. Hyperbola is a curve traced out by point P moving in a plane such that the difference of its distances from the fixed points will remain constant. And third definition is the definition of the parabola. Parabola is a curve traced out by point P moving in a plane such that its distances from the fixed points will remain constant. So this is all about today's lecture. In the next lecture we will explain different methods to draw ellipse. Thank you.